Question 8. We're given a differential equation dq dt is equal to kq, which is supposed to represent the rate of decay of radium. We're told that it takes 1,600 years for any mass of radium to reduce by half. So this is the half-life. In part A, we're asked to find the value of K. You should know that this type of differential equation, if we solve by separating and integrating, will lead to a formula of the form that Q at any time is equal to the initial Q times E to the KT. Since we're talking about decay, K will end up being a negative constant. The half-life is 1,600 years. So it follows that Q will be equal to a half of Q naught when T equals 1,600. That gives us that E to the 1,600 K is equal to 0.5. Now, you can either solve this using your knowledge of logs or solve it on the calculator.
We want to solve e to the 1600k equals 0.5. Go to Action, Advanced, Solve. On the keyboard, e to the 1600, it's easier just to use x here. Close the bracket, equals 0.5, close bracket, and execute.
K is negative 4.332 times 10 to the power negative 4. Now moving to part B. We're told that a factory site is contaminated with radium. The mass of radium on the site is currently 5 times the safe level. We want to know how many years it will be before the mass of radium reaches the safe level. We need the mass of radium to be 1/5 or 0.2 times the initial amount. Substituting what we know into the equation then, we want 0.2 Q naught to be equal to Q naught times E to the negative 0.004332 times T. The Q naughts can cancel, so 0.2 is E to the negative 0.004332 T, and once again we can solve using our knowledge of logs or solve on the calculator.
We now want to solve 0.2 is equal to e to the power negative 4.332 2 times 10 to the negative 4 times x, and execute, and we get 3715.23, and so on.
This gives us that t is 3715.23 and so on, so that's 3715 years.